fields, providing facilities while applying in many engineering processes. Its applications also helped in the development of engineering. With these words, may we invite our professor and head of science of humanities, who is strong and dedicated, that makes her to step forward and forward to attain the success. I invite Dr. Shalini Bakim Kamala ma'am, head of science and humanities, NIET, to present the welcome address. Ma'am, please.
A very warm good afternoon to you all. Actually, this is the day we used to have such webinars every time throughout the year, because learning the syllabus alone doesn't make a person with good knowledge and understanding and application oriented learning won't happen. So the overall development is possible only when the student gets the hands-on experience with that. So by having that in idea, we used to provide a lot of webinars, workshops, conferences, everything to the students. In first semester, in semester 1, actually you are having this topic in your syllabus itself. Though that syllabus you learned, we need you people to have additional knowledge given by the people who's really expert in that. So one such program is organized with the resource person, Dr. T.C. Sabarigirisan, Assistant Professor, School of Physics, Bharatidasan University, Tiruchirappalli, on the topic Perspectives of Lasers for Engineering Graduates, Science to Technology. On this occasion, I am very much happy to welcome our management people, our trustee and the Sion secretary in their absentia. Like that, I'm happy to welcome our principal, Dr. P. Maniyarasan sir, also in his absentia. He conveyed his wishes and regards to the resource person as well as participants. And I'm very much happy to welcome today's resource person, Dr. T.C. Sabarigirisan. We both worked in Bishop Heber College. Many times I thank God for having the opportunity to work in Bishop Heber College. Actually, after a long time, I have another reason to thank God that since I worked there, I got very nice friends like today's resource person. So immediately I just texted, he accepted. Being a person who worked in university, he never showed any different kind of gestures. Your down-to-earth nature is the reason for your hike, sir. First of all, we thank and appreciate for this. And the real intelligence is the reason behind everything. That intelligence makes perfect when it is shared to all. Sharing intelligence must take place in the proper way, especially sharing our knowledge and intelligence to the students should move in the right track. Actually, Dr. Sabarigirisan is a great person in that, because he was the youngest coordinator of the Shift 2 program, different programs in Bishop Heber College. In that, among all the programs, he was the youngest coordinator, but with a very mature mindset, he handled students. And the way in which you conducted various seminars, conferences, and especially our examination conducting procedures and handling the departments, everything still I remember, sir, the very matured and very smart way of handling things. But having hard work alone doesn't work out in many places. But being smart as well as with a lot of humanity, you work. Such a person, when you share your knowledge to our students, it's a great blessing to us. I'm happy to welcome our resource person to this program, and I'm also happy to invite our faculty members who have arranged all the necessary behind works, and especially all the students who prepared all the activities. And also, I'm happy to know that students, you're preparing flyers or you're doing all sorts of work. So your involvement matters here. So a part part of our department association activities from Science Club. You have made it. I'm very much happy to appreciate you also, students. So this is your day. You all please enrich your knowledge. I'm happy to welcome again our resource person, Dr. Sabri sir. Welcome you, sir. Thank you.
Thank you, ma'am. May we invite Atin KV, first year Computer Science Business System, to introduce the resource person and his records. Atin, please.
Thank you, ma'am. Let me take this good time to honor our resource person and his records. He has 16 years of experience in teaching and got research experience for more than 15 years. At present, he is an assistant professor in physics at Bharathidasan University, Tiruchirappalli. He held various positions such as counselor in physics at IGNOU, Tiruchirappalli, 2006 to 2012, and the Faculty of Physics at Healthcare Management International Learning Center, Emilio Aguinaldo College, Philippines, 2006 to 2008. His achievements are: he was awarded for 11 projects and 2 ongoing. His publications was around 77 in national and international journals with highest impact factor 5.12. He acted as a reviewer of peer-reviewed for 15 journals. He presented 92 papers in conference. He guided 4 PhD, 7 MPhil, and 44 MSc Physics graduates. He received grants from funding agencies from RUSA, Tamil Nadu Science and Technology, Material Research Society, and many more. He acted as a camp officer, PG, Central Valuation, Bharathidasan University, Tiruchirappalli, and also academic council member as well as member in Board of Studies. He invited for special talks for different talks in physics. He participated in refresher courses and orientation programs and achieved a milestone of success. May we invite our resource person, Dr. T.C. Sabri Girsan, Professor Nanophotonics, Laboratory School of Physics, Bharathidasan University, Tiruchirappalli, to take over the session. It is all from you now. Welcome, sir. Sir, please.
Thank you, Atin. So I will share my screen first.
Yeah, sure, sir.
Well, I think the screen is visible.
Yes, sir, it's visible. You can continue, sir.
Thank you. Ma'am, how long can I proceed till 4 or 4:15?
Sir, as you wish.
Okay, ma'am. Right, I will try to wind it up by 4. So 45 minutes. If necessary, we will go for it.
Yes,
yeah,
okay.
Please. Yeah. Okay. So before I begin up my duty of assignment today, I take this opportunity to thank the management principal and the head of the Department of Physics for inviting me to be in your midst. Of course, a special word of thanks to Shalini ma'am for giving me some time to recollect quickly what we have experienced at Bishopur College. Right? Once there in your institution, right? Unfortunately, I couldn't meet you all by person, but anyhow, right? I am happy that I am all meeting you through this particular online platform. As ma'am pointed out, I have accepted this invitation just for one reason, that it was an invitation from your head of the department, Shalini ma'am, because nowadays there are too many number of webinars happening. So I just thought that this may actually find difficult for the students, but anyhow, I'm happy to hear that you have attended more than 50 webinars, and the things were very helpful for you to improve your knowledge. With this note, I take this opportunity to thank specifically the head of the department the various faculties of School of Science and Humanities, and all the participants who have gathered here. So today my job is I'm going to give a presentation on lasers for engineering graduates. Of course, my ideology is very simple, that I just want to make the participants to think out of box, because being an engineering graduates, I just thought that I could find some way to educate you to fill a gap between science and technology, which was going to be one of the most important factors that is going to influence the development of this particular nation. Of course, I have gone through the syllabus through your head of the department, and I have just taken a couple of points from that particular syllabus to start out with, so that you will find it a bit easier to follow, right, what we are going to speak. Since you are the first year graduates, I just thought that I should not get too much of science, and of course not too much of technology, right? So it will be something fundamentals, wherein you will get the opportunity of recollecting what you have learned so far. And I will also give you some platform to think something beyond your textbook. And of course, as a graduate, I will recommend you some of the latest technologies where you can seriously look for. Right. So this is going to be the ideology I'm going to impose in this particular discussion. To start out with, of course, this is a pandemic situation. The word corona has almost changed our entire life, right? So I call the day to be BC and AC, right? So before corona and after corona, our life has changed completely, right? So this is how we normally start our day, right? Which we call it as a daily routine. We start from our bed and we go to our bed, in which we do a lot of activities, right? Starting from home, moving towards the college, doing work, getting back to home, taking rest, something else like that. Right? So suddenly, when this particular corona entered our life, we were asked to do all these particular things once again, but this time we were restricted to stay within our home. Right. So although the duties that we are performing was the same, the things has become very chaotic. Right. So the point I will start out with this is that this pandemic situation teaches us one important thing: a life that was looking very routine, which I call it to be cyclic, right, has now suddenly become chaotic. Right. Even though the circle remains the same. Right, we find it very difficult to perform our duties, right? So this particular nature always mentions us that this world is not linear, right? I'm going to talk something about the world of non-linearity in optics, and I want to start with this word non-linear, right? That nature teaches us always that, right? This world is always non-linear, right? Since you are after lunch. Of course, I am a type of speaker who always wishes to have more interactions with the participants. Unfortunately, we cannot do it. I will impose a question then and there. You try to answer by yourself. Right. So I will start with one funny question. Right. So what changes its state from liquid to state at very high temperature? You just have a think over it. Right. So that it will be funny for you to understand why science is always to be rejoiced as a simple one and not as a complicated one, right? So before I go to that particular official business, let me introduce you one molecule, right, which we call it as dihydrogen monoxide. This particular molecule was actually presented by one person by name Nathan, right, in a presentation like this, right? So the ideology is not to give you anything very serious, just to make you to get aware, right, what you should think of seriously, right? So I'm just borrowing the content of Nathan, right, from his presentation. I'm just giving you Nathan's presentation was to introduce some molecules, right, and he called that molecule as dihydrogen monoxide. And he narrated that dihydrogen monoxide is the most dangerous material that human has ever encountered, right? For that, he has given some n number of reasons, like it kills countless amount of people annually, it causes severe burns in gaseous form, it is available in tumor, acid rains, and etc. etc. Right? After giving a very big elaboration, right, what Nathan did was, out of the 50 participants who are available in that particular forum, he convinced 43 people, right, that dihydrogen monoxide is the most toxic chemical, right, available in this world, right, and he made everyone to accept that it should be banned, right. Very interesting factor is that, right, after finishing all that, he introduced that particular dihydrogen monoxide is nothing but water, right. The title of this presentation was "How Global Are We?" Right. You all know that water is nothing but H2O, which can be commonly called as dihydrogen monoxide, right? And after this presentation, right, science got a new word called as johannerism, right? So johannerism is the use of a fact to lead scientifically ignorant people to a false conclusion, right? I'm starting with this word johannerism because nowadays science and engineering has become too much complicated, right? When we make attempt to explain what we are doing, no one understands it. Especially when you go for science and most particularly physics, it looks very complicated because rather explaining a physics in a simple manner, right, we always make attempt to people feel afraid, right? So let's avoid johannerism, right? To understand johannerism in a simple word, right, I could answer you one question which I have asked you, right, to think of before we go to this particular plan of talk. I have asked you to think a material that changes its state from liquid to solid at high temperature, right? You all know that when temperature rises, normally the material melts. That is, the material can become solid to liquid, but I have asked you something very specifically, right? What changes its state from liquid to solid, right? It's a food, right? The answer is going to be idli, right? So idli, you all know that it is in a liquid state, and when it is heated up, it becomes solid, right? So the point I want to start out here is that I call this one to be johannerism. I can talk more about this material to be a very big deal, and at the end, if I say it is nothing but idli, right, we will all get irritated, right? So I'm not going to do any johannerism here. I'm just going to make you some simple attempt to talk something about lasers. I will try to introduce you something about nonlinear optics. At the end of the session, right, you will understand a term called as frequency doubler, and one of the most fascinating technology what we are looking for in modern pandemic situation like UV sterilizer and how it actually works with lasers, right? So this is going to be the place where I'm going to begin. Of course, it's all about laser. Right, someone says optics is the study of light. Right, if you look at the past, present, and future of light, you can see it through these three pictures. Right, when human evolved, right, light was along with us, and initially man used fire to be his light source. Right, and later when electricity was introduced, no longer we have darkness. Right, our life has become very colorful. Right, and there were n number of light sources available throughout the world that works on electricity. Right, so lamps comes to the picture. Right, so this is the present era. If someone asks you, right, what will be the next one, right, or what will be the next one, right, the next light source, what we can think of, I will say it is going to be laser. Right, you have a look at this third picture. Right, this room is actually illuminated with lasers. It's not with light. It is actually illuminated with laser. Right. So whatever you see here is in fiber optics, a transparent fiber optics. Right. You have studied fiber optic communication, and you know that fiber optic communication works on the principle of total internal reflection. And this is going to be a partially transmitting fiber optics through which lasers were allowed to pass through. Right. So the advantage of this one is that we all know that, so for supplying water, we have a water tank, and for supplying electricity, we have an electrical board. So we have a central unit from which the energy is distributed. Like that, in future, not all the rooms will have light sources. Rather, there will be one light source commonly available for a building, from which light will be transported through pipes, which we call it as fiber optics. And according to the intensity requirement, right, you can illuminate your room with these lasers, right? So this is a prototype building that has been prepared by illuminating them with laser. Of course, there are plenty of science behind it, right? And this is going to be the future, right? So this is going to be the future, what we are going to look for, right? I will take it as a point of note to make you understand that laser is going to be a very important light, right, as far as our future is concerned, right? So to start out with, I will start with a very famous statement, right? All light sources are not the same. Right, I have given you some n number of light sources here: sun, lamp, candle. Right, of course, living organisms that emit light, radium. Right, you have incandescent lamps. When you have a close look at these particular light sources, the physics behind this light source is going to be different. You all know that sun works on the principle of nuclear fusion, and bulb works on the principle of electrical discharge, and candle works on the principle of combustion. And this is going to be bioluminescence, radioluminescence, and of course, this is again a form of electrical discharge. All right. So these are the different type of light sources available. All right. And I can introduce you one more light source, which we call it as laser, which is commonly expanded as light amplification by stimulated emission of radiation. All right. So when I introduce this word laser to you, all right, I have given specifically its expansion. All right. And I want to make you a mention that out of all the light sources available, right, laser is going to be entirely different from all other light sources just because of one reason, that this is the only light source that works on the principle of stimulated emission, right? All these particular light sources that are known to us works on the principle of spontaneous emission, right? So to just have a look, I will start with the things that you have studied in your first semester, Einstein coefficient. Right, so the light, when it interacts with matter, right, they can be classified into three processes. One is absorption, and the other one is emission, and emission can be divided into spontaneous emission and stimulated emission. Right, very interestingly, right, initially people believed that when light interacts with matter, there are only two things happening. One is absorption, and the other one is emission. Right, when light falls on a material, the electron goes straight to excited state. We call this process as absorption, and from the excited state, the electron gets back to its ground state, right, by emitting the same photon outside. We call this as an emission, right? This was the theory that were available in the beginning of 19th century until Einstein proposed concept of stimulated emission. Of course, we call that one to be a negative absorption, right? You have derivation, theoretical derivation, in which when Planck's radiation law was attempted to be verified, right, people found that it was not exactly true when you consider the interaction of light to be absorption and emission alone, right? At that time, Einstein introduced one theoretical equation, right? The equation that you see here, right, is the equation that was introduced by Einstein to explain, right, how a spontaneous stimulated and absorption works, right? When a light moves from, when an electron moves from one state to another, the rate of change of number of molecules in the excited state can be written of this particular form, right? The absorption is the process in which, right, according to the work function, the number of electrons moving through from N1 state to N2 state will decide the rate of change of the molecules in the excited state, which is given here. Right, and spontaneous absorption is going to be, right, the process in which the light is emitted back by the electron, right, which we call it as absorption coefficient, and it depends upon the total number of molecules available in the N2 state, right, E2 state, right. But Einstein believed that apart from these two emissions, there can be one more emission called a stimulated emission, right, and because those electrons which are capable of getting back to its ground state spontaneously, if they are hit with one more photon, right? If they are hit with one more photon, they emit the two photons at a time and they get back. And he called that particular process as stimulated emission, right? And when stimulated emission was introduced, right, Einstein called this particular phenomenon to be the game-changing phenomenon because stimulated emission was not realized, believed that there is an emission called the stimulated emission when a light interacts with matter, right? And this was proposed in the year 1916, and he proved some various concepts like this absorption should be equal to the sum of spontaneous and stimulated emission, and he also proposed that this spontaneous emission will be always equal to stimulated emission, right? Like that. He has given some various descriptions. I will not go deep into it. All right, and when this stimulated emission was actually introduced, in 1916 by Albert Einstein, people started looking for a light source that works on the phenomenon of stimulated emission, right? But very interestingly, it was almost a scientist by name Rudolph experimentally demonstrated stimulated emission in a laboratory, right? So it took 12 years emission exists. And after that, Arthur Scavell, demonstrated population inversion. You all know that what is population inversion is. It is the total number of molecules when being more at the excited state than at the ground state, right? So for stimulated emission to take place continuously, you should have more number of molecules at the top, right, at the excited state, and to achieve population inversion, you have to create some artificial mechanism because it was against the thermodynamical law, right? And Arthur Scavell in 1913 successfully demonstrated population inversion in the laboratory, right? So stimulated emission exists, population inversion can be achieved, but still then it took 20 years for the people to demonstrate the first of its kind called as maser, right? It was Korkov and Vazov from Russia and Charles Towns and his team from Colombia, right? Both of them parallelly invented the microwave lasers, which we call it as laser. And after that, from that 10 years, the first successful laser was demonstrated, which we call it as Ruby laser, and it was by Maiman, right? In the same year, Ali Jawan introduced helium neon laser to the world. He was the father of lasers, right? But interestingly, it was not Maiman, right? It is Albert Einstein, because a laser is a light source that works on the. I have one interesting factor for you to share.